Let us now try to explain the shape of methane using the concept of hybridization. Here the central atom is carbon, atomic number 6, and the electronic configuration is 1s2, 2s2, 2p2. So in the ground state, the electronic configuration of carbon can be written as 2 electrons in the 2s orbital and 2 electrons in the 2p orbitals. In the excited state, there will be promotion of 1 electron from the 2s orbital to one of the vacant 2p orbitals. After that, one 2s orbital will mix with 3 2p orbitals to give 4 sp3 hybrid orbitals. Therefore, carbon in methane is under sp3 hybridized state. 4 sp3 hybrid orbitals will be available with carbon. Next, we have to consider how the 4 CH sigma bonds are formed. Each of the CH sigma bond is formed by the overlap of the sp3 hybrid orbital of carbon with the s orbital of hydrogen. The 4 sp3 hybrid orbitals will be oriented at an angle of 109 degree 28 minutes. Therefore, methane molecule is tetrahedral. Consider the next molecule, ammonia. Here the central atom is nitrogen. Its atomic number is 7. So the electronic configuration can be written as 1s2, 2s2, 2p3. The ground state electronic configuration can be shown as 2 electrons in the 2s orbital and 3 electrons in the 2p orbital. In the excited state, there is no change in the electronic configuration. It is the same as in the ground state. Note that the 2s orbital has a pair of electrons. So here in the case of ammonia, one 2s orbital will mix with 3 2p orbitals to give 4 sp3 hybrid orbitals. Therefore, nitrogen is under sp3 hybridized state. 4 sp3 hybrid orbitals are thus obtained. Here you should note that out of the 4 sp3 hybrid orbitals, 3 of them will contain 1 electron each, and the 4th sp3 hybrid orbital will be having a pair of electrons. This is actually the lone pair of electrons which is present in nitrogen. Let us now consider how the NH sigma bonds are formed. Each of the NH sigma bond is formed by the overlap of the sp3 hybrid orbital of nitrogen with the s orbital of hydrogen. Nitrogen has one lone pair of electrons and it is present in one of the sp3 hybrid orbital. Here in the case of ammonia, there will be bond pair repulsion as well as stronger lone pair bond pair repulsion. Therefore, in order to minimize the repulsion, the orbitals containing the bond pairs of electrons will be oriented at an angle of 107 degree. The molecule ammonia is therefore pyramidal. Consider the next molecule, water. Here the central atom is oxygen. Its atomic number is 8 and the electronic configuration can be written as 1s2, 2s2, 2p4. In the ground state, the electronic configuration will be 2 electrons in the 2s orbital and 4 electrons in the 2p orbital. The excited state electronic configuration is also the same. There is no promotion of electrons. Note that the 2s orbital has a pair of electrons and a pair of electron is also present in one of the 2p orbitals. Here, one 2s orbital and 3 2p orbitals will mix together to give 4 sp3 hybrid orbitals. So here oxygen is under sp3 hybridized state. Out of the 4 sp3 hybrid orbitals, 2 of them will have a pair of electrons and the remaining 2 sp3 hybrid orbitals will be having only 1 electron each. Now let us see how the OH sigma bond is formed. 2 such bonds are present in water. So each of the OH sigma bond is formed by the overlap of the sp3 hybrid orbital of oxygen with the s orbital of hydrogen. Two of the lone pairs of electrons present in oxygen will be present in two of the sp3 hybrid orbitals. So here there will be lone pair repulsion, lone pair bond pair, as well as bond pair repulsion. So in order to minimize the repulsion, the orbitals will be oriented at an angle of 104.5 degree. Therefore, water molecule is bent shaped or V shaped. Consider ethene, CH2 double bond CH2. The structural formula of ethene is given. From the structural formula, it is clear that each carbon has to form 3 sigma bonds and 1 pi bond. The pi bond is formed by the sideways overlap of the orbitals. Consider carbon atomic number 6. Its electronic configuration is 1s2, 2s2, 2p2. The ground state electronic configuration can be shown as 2 electrons in the 2s orbital and 2 electrons in the 2p orbital. In the excited state, 1 electron from the 2s orbital will be promoted to the vacant 2p orbital. Here, there should be one unhybridized p orbital available with each carbon atom that is required to form the pi bond. So, one 2s orbital will mix with only 2 of the 2p orbitals, and that gives 3 sp2 hybrid orbitals. Therefore, each carbon atom in ethene is under sp2 hybridized state. Each carbon is under sp2 hybridized state. 3 sp2 hybrid orbitals will be available with each carbon atom. Now let us see how the carbon-carbon sigma bond is formed. It is formed by the overlap of the sp2 hybrid orbital of carbon with the sp2 hybrid orbital of the other carbon atom. And how is the CH sigma bond formed? It is by the overlap of the sp2 hybrid orbital of carbon with the s orbital of hydrogen. And how will the carbon-carbon pi bond be formed? By the overlap of the unhybridized p orbitals present in both the carbon atoms. If we consider the px orbital as the unhybridized p orbital with one carbon, this unhybridized px orbital of one carbon will overlap in a sideways manner with the px orbital of the other carbon atom, and that is how a pi bond is formed between the two carbon atoms.